Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Mu'min bin Akbar and I am one of the representative for our group presentation. We are from group 15 and together with me are Mr. Nabil and also Mr. Shawal. I will begin with our circuit design process. In the early stages, we came up with two initial designs. The first design used 4 switches, while design number 2 used 3 switches. So after comparing both design, we decided to choose design number 1 as our base because it was more suitable for our intended output. Initially, we tested the circuit with only one output to ensure that the circuit was functioning well, properly. After confirming that it worked, we continued improving upon it and we added the second LED, which is the second output. Some modifications were made along the way during this stage to accommodate more and additional output. Next, we translated the circuit from Tinkercad simulation to a real breadboard circuit. As you can see, there are small differences between the Tinkercad design and the real circuit. These changes were mainly due to practical limitations and the use of different gate outputs, especially for the second output, which I will explain further later in the presentation.
Hello, my name is Muhammad Abi Shahni Biarozali. My metric number is 23304445. So I'm gonna explain how the REX LED work in the circuit. Basically, the red LED is connected with two logic gate, which is AND gate and OR gate. So for the AND gate, you need both or switch is on, while the for OR gate, you need one of the switch is on for the LED to work. So as we expected, the LED is work properly and exactly like the truth table that we get and the SOP expression that we obtain.
Okay, next, for the Kanav map of the blue bulb, there are 10 places where the blue bulb became high. So for the first group, in the red square, which include 0001, 0011, 0101, and 0111. So from the all 0 and all 1, we get A over bar and D. So for the next group, in the green square, we will get A over bar C. Next, we can roll up the map to get the combination from the top of the map and from the bottom. So in the purple square, we get B over bar D. And same like in the yellow square, we will get B over bar C. And lastly, in the last group, which only include one number, which is 1100, we will get AB, C over bar, D over bar. So we add all the combination to get Boolean expression. So we get A over bar plus B over bar times D plus C plus AB C over bar D over bar, which is the final Boolean expression.
Now I will explain what will happen if floating occurs to one of our gate. First, signal instability, which means the output may be glitched and trigger unwanted logic circuits. Second, device may damage or resulting overheating and failure. And the lastly is system malfunctions, which means the input may randomly read 0 or 1, which we don't want to happen because it will alter our result.
So let's go to our final agenda, which is problem and solutions. So one of the problem that we encountered is circuit works in Tinkercad but did not function properly on the real breadboard. So what does that mean? When we do our real circuit, we found that the circuit itself works, but the output given by the LED is different compared to our truth table that we constructed. So we found that some of the logic gate did not work properly. So there are some pin that is not working. So hence we managed to overcome this issue by placing the wire in the different pin, and it worked. So another thing that we encountered is some of the floating issue occurred in our circuit. So to encounter that, we added pull down resistors to the ground, so when the switch was off, the input would stay at logic low. When the switch was on, the input would receive a clear logic high. So lastly, I want to talk about bridge wires. So as you can see in the Tinkercad and also in the real board, in the real circuit, as you can see in the upper left and also in the lower half, there aren't any bridges in the Tinkercad. Meanwhile, in the real circuit, there are some bridge wires. So why is this occur? Because the bridge wires are not always necessary in the simulation in the real breadboard circuit. The internal connections of the breadboard are limited and segmented. So some rows and columns are not electrically connected, especially across the center gap of the breadboard. Because of this, we needed to use bridge or jumper wires to connect components that could not be linked directly. So that's all for our group number 15. Thank you.